Hi, how's it going? Welcome to Code with Z. Today's problem is a classic one, LeetCode number 1 2 sum. Let's solve it together. This question gives us two pieces of information. One is a target number and the other is an array of numbers. And it asks for the index of the two numbers in our array that if we add them together, they're gonna be equal to the target number. So we're gonna be like 2 plus 15 is 17. Is 17 equal to 9? Nope. But if we get the sum of 2 and 7, that's gonna be equal to 9. But how do we do this programmatically? The most brute force approach would be having two loops, because in the first loop, we're gonna take one of the numbers, and then we're gonna compare it to all the other numbers in the second loop. And when we find an answer, we're gonna return the answer. This will definitely solve the problem, but the issue is because we have two loops, it will give us the time complexity of n squared. And we don't want this, especially when there's another approach that can solve this problem with the time complexity of just n. For this approach, we're just gonna need two things. One is a loop, and the other one is an object. A special type of it, which I'm gonna elaborate on later, but for now, just think of it as an object, trust me. Alright, we have our array here, the target number over here, and the object that's currently empty over here. So we're gonna loop through this array. The first index of the array is 2. Buckle up, because this is the secret sauce to solving this problem. On each iteration, we get the target number, which is 9. And we also bring the current number, which is 2. And we subtract them from each other. And we get 7. This number here is called the complementary number. But what this in plain English means is that 2 plus 7 is equal to 9. So if your current number is 2, if you have a 7 stored, that's your answer. You don't need to look for anything else. But where should we check to see if we have already stored 7? Well, in our object. As you can see, our object is empty because this is the first iteration of our loop. So we're gonna be like, does 7 exist in this object? And we're gonna say no. If it doesn't, add the current number to the object, which is 2. And you might ask, why did we add 2 to the object? You see, 2 plus 7 equal 9. But 7 plus 2 also equal 9. So in the future iterations, if we have 7 in the array, we're gonna be like target number, which is 9, minus current number, which is gonna be 7, is equal to 2. Does 2 exist in this object? The answer is yes. And that's gonna be our answer. That's why we're gonna store the current numbers in the object so that in future, if their complementary numbers exist, we're just gonna then return the current number and it's complementary. Let's keep tracing this algorithm so it becomes more clear how it works. So we're gonna move to the next iteration and our current number is gonna be 11. We're gonna calculate the complementary number again. So we're gonna be like target number, which is 9, minus current number, which is gonna be 11, is equal to negative 2. Does negative 2 exist in our object? No. Alright then, add the current number to our object. We're gonna add 11. Now we move to the next one. We're gonna bring 9, which is the target number, minus 15, which is the current number. It's gonna equal negative 6. Do we have this in our object? No. Alright, instead store the current number in our object, which is 15. And finally, we get to the last number, which is 7. We're gonna calculate the complementary number, which is gonna be 9 minus 7. And it's gonna be 2. Does 2 exist in our object? Would you look at that? It does. Awesome. In that case, 2 and 7 are our answer. But there's one issue. We don't want the values of these two. We want their indexes. So instead of returning 2 and 7, we should return 0 and 3 because the index of this one is 0 and the index of this one is 3. That's why in the beginning I said we're gonna have a special type of object and that's gonna be a map. During our iterations, each time we store a number, we're gonna store the index of that number as well. And then we're gonna return these indexes that we have here together as the answer, and this is our answer. So we literally have whatever we had in the object, but with the current number that we're gonna store anyways, we're gonna also store the indexes. That's it. Now let's code this. So first I'm gonna initialize my map, which I'm gonna call value to index. Let's initialize it. And that's literally it. Then we're gonna define our loop while I is less than the length of our array and I++. We're gonna define our complementary number, which is gonna be the target number minus the current number. So this gives us the complementary number. We're gonna check if the complementary number exists in the map, but before that, I wanna show you how we add the numbers to the map in the first place. And we're gonna map it this way. So the value and its index. But we also need to return the right answer, right? So if this value to index map has the answer, meaning the complementary number exists inside of it, we need to return the answer. So before this line, we're going to add an if statement, and we're going to say if value to index map has the complementary number, return the index of the current number and the index of the complementary number, which we're going to get by giving it the complementary number. This is going to say, does 2 exist in this value to index map? If so, return the index. This will give us the index of the complementary number, and this is going to have the index of the current number, and then we're going to return this. So let's check if this solution is going to pass our tests. Yep, as you can see, all 3 of them. Let's submit it. Moment of truth. Drum roll, please. I'm just kidding. There we go. Don't forget to like and subscribe, and catch you in the next one.